Okay, I lost track of my time and my video ran out, so we'll just pick up right here. I was looking at your uncertainties here and trying to figure out what exactly you were propagating. This looks like a propagation in the force reading, but it's not obvious. This could be a propagation in force. Okay, those are propagations in the measured force. Okay, so that's what I think this is. Measured forces. Okay, so again, I can't tell if these are measured uncertainties. Yeah, those are measured uncertainties in your forces. Okay, sorry, it's not clear from anything you've done here what these things refer to. So what needs to happen is that you've made these measurements. You know, your model looks something like this. Tension is mu mg over, should be, cosine theta plus mu sine theta. And so in your prediction of the tension, you've got some uncertainties in mu. I don't see those anywhere. You've got some uncertainties in mass, which could be, which is what that is, but I don't know why the mass uncertainty would be propagated with these values here, because I don't know what those are. So you have an uncertainty there, and you have some uncertainty here and here. And so these uncertainties propagate to a uncertainty in the tension. The model, in other words, the model has some uncertainty associated with it. And then you actually have your tension data, and that has some uncertainty in it. And so again, going back to your graph, let's say your model looks a little bit like this. Then for every data point, you could have whatever the uncertainty propagated here, you could have little error bar deals going like that, something like that. And then you have your actual data points that come in here, and maybe those for you guys might have gone somewhere like that, but then even those have some uncertainty with them. And those uncertainties are what I think you've got back here. I think those are the uncertainties associated with each of those. So that's the way that this ought to be done. And again, as an option on this model, you could trace out sort of the upper and lower bounds is another nice way to do that. But at any rate, the only way, real good way to judge the fit of model and data is to compare the uncertainty in the model, to look at the uncertainty in the model and how that overlaps with the data points, but including their error bars. All right, so just taking the paper from top to bottom again in a quick summary. In the beginning, we talked about some issues here in the abstract related to the model, and that comes back again and again in a representation of the comparison of the model and the data in the derivation of the model. And so while while you did an excellent and very efficient job, nice quick job taking data on the experiment, it seems like there were some things that were missed in terms of the presentation of the data, and then in the derivation of the model, and then how that relates to what you portray in the graph. So, well, it's an interesting experiment. I think you collected good data